Motor is an important invention for modern day life. Every day we use motor in some way, like fan, cooler, AC, or children's toys. In today's video, we'll know how DC motors works. Any motor is made up of current and magnets. So before we get into how motors works, let's learn a little about magnets. It is a bar magnet. Bar magnet has two poles, north pole on one side and south pole on the other side. From general physics, we know that similar magnetic poles attract each other and opposite repel each other, as shown on the screen. Now, if we stuck a bar magnet in the middle with a rod and bring another bar magnet near the stuck magnet, then similar pole will repel and opposite pole will attract. This will cause the stuck magnet to rotate. If you bring the magnet around the stuck magnet in this way, now a solenoid is placed in the place of the stuck magnet. We know that if current flows through a conducting wire, a magnetic field will be created around it, and if current flows through this conducting wire like a string, two poles will be created. That is, it will act like a bar magnet. Now, by stocking this solenoid with a pin, bringing a bar magnet close to it, it will start reacting. And by bringing the bar magnet closer as before, it will start rotating in 360 degrees. Now, two bar magnets are kept curved like this, which are placed in such a way that there is north pole on one side and south pole on the other side. Now, if we observe, we'll see that the magnetic field line will be from south to north pole. A rectangular current loop is placed between two magnets instead of a solenoid. Now, connecting the current loop to a battery will create a north pole at the top of the current loop and a south pole at the bottom. The north pole of this system will be attracted by the south pole and the south pole by the north pole. As a result, the loop will start rotating. Now, if you repeatedly change the positive and negative terminals coming from the battery, the north and south poles generated in the loop will also change. As a result, the current loop will start rotating continuously. But it is not possible to change the connections of the battery repeatedly. So instead of connecting with the battery, a circular metal plate is added. It is called commutator. Both ends of the current loop are connected to two circular plates, and two brushes are in contact with this plate, and the battery is connected to these brushes so that current can flow in the current loop. As a result, the circuit rotates continuously. But there are some problems here too. There is a possibility of a short circuit if the brush comes between the two plates of the commutator. To solve this problem, the commutator is divided into 4 instead of 2 plates. As a result, there is no problems of short circuit. And by increasing the number of plates, the number of circuit loops will also increases. The more the number of current loops, the more smoothly the coil will turn. Not only this, the torque of the motor will also increases. The circular coil is thus placed on an iron rod and a cylindrical rod is used as the center. This cylindrical rod is called shaft. This part of the motor is called the rotor, which rotates while the motor is running. The magnets on both sides of the rotor are called the stator. In a circular loop, the greater the amount of conducting wire, the greater the magnetic field produced. As a result, the speed of the motor will increases. Hence, more wires are used in modern motors. The motor's rotor, stator, commutator, brushes are covered in a metal cover. I think you understand very easily. If you like this video, please like, share and subscribe. Don't forget to follow our Facebook page, Physics First. For more details, visit our website physicsfirst.com. Thank you for watching Physics First.